So let's take a look at question 9909. It says refer to figures 27 and 28. What are the approach speed and ground roll when landing under conditions B37? So right away it's asking us for two things. We need to figure out the approach speed and we need to figure out the ground roll. So we'll go to figure 27 and go ahead and highlight your conditions. That's AC37. I know there's a typo here, but just make sure that you're focusing on the right figure. The typos are not a huge deal. So we know that we're going to get our ground distance or ground roll from our actual chart here. And then if you look right above that, it gives you these approach speeds. So this is where we're going to get our approach speeds. We have two steps to this. We have the chart, and then we're going to have to interpolate for the approach speeds, which requires a little bit more math. So we're going to go ahead and just start at our chart here. So let's go ahead and highlight all the information we need for this chart. We need outside air temperature, we need pressure altitude, we need weight, we need wind component, and we need an obstacle height. And so now that we know that, go ahead and highlight your reference lines. If you're in your own book, you can actually highlight these reference lines. You won't be able to take your book into your exam, but if you highlight the reference lines, it'll help you in your studies. So now that we have the reference lines highlighted, we'll just go about the chart as normal. So we're going to go over here and look at our temperature outside and our pressure altitude. So we have positive 16 degrees and a pressure altitude of 1,000 feet. So we'll enter the chart down here at 16 degrees Celsius. So 12, 14, I'm going to say 16 is right there at that red dot. And then for 1,000 feet, I'm going to try and draw a line down the middle as best I can. Again, remember, you can always use a ruler or a straight edge. That will help you get your lines as straight as possible. Once I have that figured out, I'm just going to draw that line directly over to the reference line. And then now I'm going to have to account for my weight. So my weight is 14,500 pounds, and I'm going to make a mark right in the middle here and just draw my own temporary reference line. That way I know how far down to bring this red line. So I'm bringing the red line down to that reference line I've created, and I'm following as best I can the angle of the chart. And then we can bring this line directly across to our next reference line. And now we're accounting for our wind component, and our conditions say that we have a 10 knot tailwind. So I'm going to go ahead and draw a line at 10 knots directly up. That way I know where I'm ending. And then I'm going to draw upwards. So remember that for a tailwind, you'll draw up like this because you need more distance. So that tailwind is going to push you further across the runway. And so you have to account for more distance. Whereas that headwind, you're drawing down because you need less distance. That headwind is helping stop you. So we're going to go up on this chart for our tailwind. So we'll just follow this line directly up to our tailwind. And then we can pull that directly across to the next reference line. And now we're accounting for an obstacle. Well, we don't have anywhere in our conditions or the questions that say there is an obstacle. So we're just going to pull that line straight across. Now, I'm going to kind of try and decide how many feet this is before I look at my answers. And I would say that this is 1,100, 200, 300, so close to 1,400. So I'm going to put 1,400 here. I mean, if you were being really specific, maybe like 1,380. So I'm saying 1,400. And that's my ground roll. So I'm going to look at my answers now. And you can already see that I have this answer B that is clearly not anywhere close. So I can just take that one out of the equation. And so I'm really deciding between 1,400 and 1,350. Here's where you have to interpolate. These answers are so close together that while sometimes you can get away with just taking a median number in these charts, you can't do that here because all of your answer choices are so close together you could very easily guess wrong. And so we're going to learn how to interpolate. And what we're doing is we're coming to this part of the chart And this part of the chart is talking about the approach speed compared to the weight. And so what we're going to do with interpolating is we're going to find our percentage between these two numbers. So we're 14,500. What is our percent of these two numbers? And then we can add that on to the approach speed. So the very first thing we need to do is we need to come over and subtract 16,100 from 14,000. So 16,100 minus 14,000, because this is going to give us the amount of difference that we're working with, and that number equals out to 2,100. So there's 2,100 pounds of difference. Now we need to figure out how far away in a percentage we are from that lowest number. So we're going to take 14,500, which is our weight, and we'll subtract 14,000. So that equals 500, which means we currently are 500 pounds of 2,100 pounds. What is the percent of that? And so what we're doing is we're going to take 500 and divide that by 2,100. And it's going to equal 0.238. Then you're just going to drag your decimal 2 places, and that will equal 23.8%. So we know that we are 23.8% higher than 14,000 feet. So we're trying to figure out 14,000 is the lowest weight. I said feet earlier. That's okay. And then 16,100 is the highest weight. And what we're doing is we're trying to be like, okay, how high are we above 14,000? Because if we know that as a percent, what we're about to do is we're going to apply that same thing to our approach speeds over here. We're going to apply that same percentage. And so our next step is to take those approach speeds and find the difference between them. So 113 minus 107. And that equals 6 knots of difference. So we apply that same percentage to 6 knots to see how much we need to add to 107. So we're going to take 6 times 23.8%, and that will give us 1.43 knots. So now we'll take 1.43 and add that to 107 because we're adding that percentage to the lowest number. So 107 plus 1.43, and that is going to equal 108.43. We won't round this up, so we'll just make this 108 knots of approach speed. And so now we can come back. We can come back and look at our answers over here, and we've determined that answer choice A will fit our needs the best. So we get 108 knots, which is correct, and 1,400 feet, which is almost exactly what we got on the chart. And so you can see here that these answers are so close together that you have to interpolate, but in basic terms, you just need to figure out the percentage of difference that you need to add to this to get to your current weight, and then apply that same thing over on this side, and that will give you the speed that you need. And that is how you can use interpolation to figure out figures 27 and 28.